And it says, replace f of x by y. So essentially, our original problem is f of x equals x cubed plus 1. What am I going to expect in my inverse? If there's an x cubed, what's the inverse of x cubed? Cube root, right? So my answer better have a cube root in it. Replace f of x by y. So y equals x cubed plus 1. Interchange x and y. So now we flip. So x equals y cubed plus 1. Now we solve for y. That means isolate y. X minus 1 equals y cubed. And how do I get rid of a cube? Cube root it. That's how the cube root gets in there. So I'm going to cube root both sides. So that y equals the cube root, make sure it's over the whole thing, of x minus 1. Because if you have the 1 flapping outside the cube root, you're going to think it's the cube root of x minus 1. So replace y by f inverse. So f inverse of x is the cube root of x minus 1. Now we're going to verify using one or the other. As my choice, I can do f of f inverse or f inverse of f, your choice. I don't care. So f of f inverse of x says in the function f, I'm going to replace all his x's by the inverse. And f itself was x cubed plus 1. So it's cube plus 1. And replacing the x by the cube root of x minus 1. The cube root of x minus 1 cubed is just x minus 1 plus 1, which is x, and it verifies. So indeed, I have the inverse. So I'm going to write these down here for a reason. And then we said f inverse of x is the cube root of x minus 1. And now they say, what's the domain and range? Well, domains are easy to find. Unless you know something about the function, the range is hard to find. The domain of f is what? All real numbers. Now, I don't know what Freddie used, but for me, when I have all real numbers, because I'm lazy, I know none of you are. I use this guy. And that's typical notation for all real numbers. You can use also, if you wanted to, minus infinity, infinity. Or you could write the words all real numbers. Or you could, in intermediate algebra, not a real number, we wrote NRN, and you could say ARN, but nobody would recognize that if you go into another class, but I would. Now, and what is the domain of the inverse? It's a cube root. It's all real numbers, right? The only one who has a restriction is even numbered even indexes. So square root has a restriction. You can't take the square root of a negative number. Fourth root has a restriction. You can't take the fourth root of a negative number. But cube root, you can take it. So he's also all real numbers. Well, then these squirrely people have the nerve to say, what's the range? And unless you graph it, on your grapher or some other piece of information, you'd have problems with the range, except we know. You're going to say, how do we know? Because we have the inverse, right? The function goes this way. The inverse goes this way. Now this one's going to be pretty silly, but when I think of it, if I'm having problems, so that's F. The domain is all real numbers. Now the inverse brings it back. His domain is also all real numbers. So when I look at the range, F goes from all real numbers to what's in this circle? All real numbers. The inverse goes from all real numbers. What's in that circle? All real numbers. So if worst comes to worst, draw circles. But they'll tell you, then we did this yesterday, this guy goes here. And this one goes there. They crisscross. But to me, if I draw a picture, I know I'm certain. Because I know what the domain of the two functions are. Problem is the range. Ranges are hard. That's why you don't find them asking you to find ranges very often. When you're dealing with a function in the inverse, you can ask the range. Well, why? Because you've got it. It happens to be the domain of the inverse, and that's what drives us crazy, by the way.